Hey, welcome to our practice test number 2 for our trigonometry class. We're going to be going through all 14 questions of the practice test. Probably this is going to be a two-part video, so we'll do 7 for part 1 and then the other 7 for part 2. So without further ado, let's get started. First of all, if you read the instructions here, it says you must show your work. Any work that's required to solve the problem, you need to show it, okay? And correct answers without supporting scratch work will not receive any credit. So you do have to show work for every problem that requires scratch work. Here we go. Number 1, find the exact value of the expression. Express your answer in degrees. So we know that an inverse trig function produces an angle. So we would say, hey, that's equal to theta. And then we're going to move the inverse sign to the other side, and that's going to turn it into regular sine. So that'll say sine theta is square root of 2 over 2. And then we know from the unit circle, sine theta is y. So we need to find an angle within the appropriate range of values that have a y coordinate of square root of 2 over 2. So remember, the restrictions for theta for inverse sine is anything from negative pi over 2 to pi over 2. So that means that we're looking in either quadrant 1 or 4 for a positive y coordinate. That's going to be quadrant 1. And that means that this angle is going to be pi over 4. Okay, so again, supporting work. And then if you want to, you can use your calculator to verify your work. So we can say inverse sine of square root of 2 over 2 45. Okay, so notice I put the answer in radians. It does say express your answer in degrees. And so that's one way to help catch a simple mistake like that, okay? So instead of pi over 4, I really should have put 45 degrees. And so we'll erase that. 45 degrees. Okay, do you see I had the correct answer, but I also have to follow the instructions. All right, number 2. Find the exact value of the expression. Express your answer in radians. So this time it's in radians. And we're finding the inverse tangent of the tangent of 6 pi over 7. Remember, the tangent and the inverse tangent will cancel, meaning that this is going to be the answer if it's within the correct range of values. So again, for inverse tangent, the range of values are also negative pi over 2 to pi over 2, and 6 pi over 7 is not between those two values. So we're going to have to find an appropriate reference angle, okay? So the first thing we have to do is to see if tangent of 6 pi over 7 would be a positive or a negative outcome. 6 pi over 7 is in quadrant 2, and we know that tangent in quadrant 2 is negative. So we'll make a note of this. Tangent of 6 pi over 7. 6 pi over 7 is a quadrant 2 angle, and tangent in the second is negative. So we're going to have to find an appropriate reference angle anywhere from negative pi over 2 to pi over 2 that would have the same value. All right, so check this out. 6 pi over 7 would be quadrant 2. And what I want to know is how many radians would it take to get on to pi? Well, if I'm at 6 pi over 7, it would take another pi over 7 to get to pi. So I know that the appropriate reference angle is either going to be pi over 7 or negative pi over 7, because both of these angles would be between negative pi over 2 and pi over 2. So I just have to figure out which of these would produce a negative value for tangent, and that's going to be the negative pi over 2, because in quadrant 1, all of the trig functions are positive. So our answer in radians is going to be negative pi over 7. Theta is negative pi over 7. And I believe we can check this with the calculator. So we're going to put our calculator in radian mode. And we're going to do the inverse tangent of the tangent of 6 pi over 7. Double close. Negative 1/7 pi, which is negative pi over 7. And so again, the calculator verifies that. And you're going to see real quick that a lot of these can be done just strictly with the calculator, but remember, you got to show your work to get credit. All right, just thought I'd throw that in there again. Next, find the exact value of the expression. So remember that an inverse trig function produces an angle. This time I'm going to take the inverse cosecant to the other side, which will turn that into regular cosecant of theta equals negative 2. And then I know that cosecant is the reciprocal of sine. So then I can say 1 over sine theta equals negative 2. And then I can simply flip both sides. So flipping this side gives me sine theta. Flipping negative 2 gives me negative 1/2. And now I'm looking in the unit circle for an angle that has a y-coordinate of negative 1/2. Again, it has to be within the correct range of values. Negative pi over 2 to pi over 2. So sine in the fourth quadrant is negative. And so we're looking for a fourth quadrant angle that has y negative 1/2. And that's going to be negative pi over 6. So our answer for this problem is going to be negative pi over 6. Now this one you can't really plug into the calculator because you don't have a cosecant button, or at least you shouldn't on a scientific. But what we can do is we can take the inverse sine of negative 1/2 and see if we get negative pi over 6. Okay, so the inverse sine of negative 1/2, and I'm going to use 0.5 instead of 1/2, is negative 1/6 pi, which is the same as negative pi over 6. And so that verifies that we're correct. Next, problem number 4. Let's see if we can find the tangent of the inverse cosine of 8/9. So an inverse trig function produces an angle, right? And so here our ultimate goal is to find tangent of theta, which is y over x. And we're going to do that first by setting theta equal to the inverse cosine of 8/9 and then solving this. So we're going to bring the inverse cosine over, which will turn that into regular cosine of theta. And then we're going to remember that cosine is x over r. So if I know x and r, I can find y. Notice I do need y to figure out this problem. So we're going to use Pythagorean Theorem to find y. 8 squared plus y squared equals 9 squared. Moving the 8 squared over. 9 squared minus 8 squared. That is not 1 squared. It doesn't work that way. 9 squared minus 8 squared is 17. And 17 is not going to square root nicely. So y is going to be the square root of 17, which means the answer to this overall problem is going to be y over x, which is square root of 17 over 8. And we're done. And I'm going to check and see if my calculator will do that. Just for fun, we're going to give it a shot, okay? Let's see. Let's do the tangent of the inverse cosine of 8 over 9. Oh, and it gives me a decimal. Well, you know what I can do to verify that? 0.515. I can put this in the calculator and see if I get the same decimal. Square root of 17 over 8. Look at that. Same decimal value. Answer verified. Yay. Number 5. Solve the equation on the interval from 0 to 2 pi. First step is to move the minus 3 over. So that's going to be 4 sine squared theta equals positive 3. And then get rid of the coefficient. Divide both sides by 4. Gives me sine squared theta equals 3/4. And then I got to get rid of the squared. So we're taking the square root of both sides. So here we can see that sine theta is, and don't forget your plus or minus because we square rooted both sides, square root of 3 over the square root of 4, which is 2. Do you see how I got that? I did the square root of the top and bottom separately, which gives me square root of 3 over 2. Okay, so now to find all of the angle thetas that will produce a solution, I need to find all of the y values in the unit circle that have either positive square root of 3 over 2 or negative square root of 3 over 2. And those angles are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now, if you're wondering how did I come up with those, I just went to the unit circle looking for all of the y coordinates of either positive or negative square root of 3. And so you either need to have the unit circle memorized or have it available somewhere. I don't know, maybe get a tattoo. That'd be great. All right, next, solve the equation. Give the general formula and then list the first 6 positive solutions. So this time they're going to want the general formula and the first 6 positive solutions. All right, so here we go. First step, notice that the trig function is already isolated. So I'm going to look for all of the x coordinates in the unit circle that have square root of 2 over 2. Positive, though. Positive square root of 2 over 2, okay? And that's what 2 theta will equal because that's the angle. The angle is 2 theta. So 2 theta will equal pi over 4. And then remember that you're going to hit that same x coordinate every time you make a full circle, which is 2 pi. So that's going to be plus 2 pi k, where k is an integer. Now, are there any other angles that have a positive square root of 2 over 2 for the x coordinate? Yes, there's also 7 pi over 4. And then remember that you're going to hit that coordinate every time you make a full circle. So we're going to say plus 2 pi k. Again, 2 pi because it's periodic, meaning that it hits that every circle, which is 2 pi. K is an integer. And then we're actually going to need to solve these for theta. So to solve these for theta, we're going to have to divide by 2 all the way through. Divide by 2 all the way through for both of those, okay? So for the general solutions for theta, we're going to have pi over 4 over 2, which is pi over 8, plus pi k. K is an integer. And for the other one, 7 pi over 4 over 2 would be 7 pi over 8 plus, and again, do you see those 2's cancel there? So that leaves me pi k. K is an integer. And I'm going to put a box around those because those are the general formulas. And then I'm going to need to list the first 6 positive solutions, okay? So pi over 8 would be the first positive solution. And the way I know that is because I'm going to plug in 0 for k first. K is an integer. If I plug in a 0, 0 times pi gives me 0. 0 plus pi over 8 would be pi over 8. If I plugged in negative 1 for k, because negative 1 is also an integer, that would give me a negative angle, but I need the first 6 positive solutions. So we're starting at 0. K is 0. And then the next positive solution would be plugging in 0 into the second general formula, giving me 7 pi over 8, okay? So after we plug in a 0 for both of those, then we're going to plug in a 1 for k. Okay, we're plugging in 1 for k. So for the first formula, it's going to be pi over 8 plus pi. Pi over 8 plus pi would be 9 pi over 8. 7 pi over 8 plus pi would be 15 pi over 8. And again, if you're wondering how am I doing that, I'm getting a common denominator for pi. So 7 pi over 8 plus 8 pi over 8. 8 and 7 is 15 pi over 8. And then guess what k is going to be next? 2, and then we'll be through. Okay, so pi over 8 plus 2 pi, that would be 16 plus 1 would be 17 pi over 8. And 7 pi over 8 plus 2 pi, again, would be 16 plus 7 would be 16 and 7 would be 23 pi over 12. What am I saying over 12? Over 8. Yeah, I'm going to check that one. Don't forget that you can use the calculator if you need to check those, okay? So 7 pi over 8 plus 2 pi, 23 pi over 8, which is what I had. Yay. So again, don't forget that you can use the calculator if you need some help adding those fractions. And that takes care of our first 6 positive solutions. So there's number 6 done. And now we're to the last problem in this video here. We're going to use a calculator to solve the equation on the interval from 0 to 2 pi. And we do need to round to 2 decimal places. So the first thing I'm going to do to solve this for theta is I'm going to bring the sign to the other side, which is going to make that an inverse sign, negative 0.45. And I do want you to notice, since it says from 0 to 2 pi, that indicates that our answers need to be in radians. So my calculator is going to need to be in radian mode, which it is. And we're going to do the inverse sign of negative 0.45. And that's going to give me negative 0.46. And that 6 is going to make that 6 round to a 7. So theta is negative 0.47. And that's radians, okay? Notice that this angle that my calculator came up with, it is not between 0 and 2 pi, okay? So that makes me have an unhappy face. So I'm going to have to do some work, okay? All right, so if we think about this, from 0 degrees, negative 0.47 would be in quadrant 4, going clockwise. And so we're going to need the two positive angles that would produce the same solution. And so those angles are going to have the same reference angle here. So it's either going to be 0.47 or the reference angle over here, 0.47 or 0.47. So I've got three angles to pick from, or it could be the positive here. If I go a full circle, it could be the positive. Yeah, okay, so I've got actually four angles to pick from. And how I'm going to eliminate two of those is, remember that sine is y, and this answer was negative. So I know that the quadrant 1 and quadrant 2 angles are out because the y coordinate in quadrant 1 and 2 is positive, not negative. So I'm going to need the quadrant 3 and 4 angle here, okay? So for the first angle, it's going to be pi plus 0.47. Do you see how I get that? If I'm at pi and I add 0.47, see that? If I'm at pi and I add 0.47, I'm going to get this quadrant 3 angle. Or if I'm at 2 pi and I back up 0.47, I'm also going to get a correct angle. Do you see that? If I'm at 2 pi and I subtract, I go backwards, negative 0.47, I get this quadrant 4 angle. So let's pull up our calculator and see what those work out to be. Here we go. Pi plus 0.47 is, now remember we're rounding to two decimal places, 3.61 rounded. And two pi minus 0.47, 5.81 rounded. And I'm going to put a box around those because I'm done. Those are my answers. And now guess what I'm going to do? I'm going to use the calculator to verify that those are correct. If those are correct answers, I should be able to plug those in and get approximately negative 0.45 as an outcome. So making sure we're in radian mode because those are radian angles. Sine of 3.61 equals negative 0.45 approximately. Yay! So that's verified. and then sine of 5.81, and that's a little bit farther off, but it's close, right? That was rounded correctly to 2 decimal places. It's a little bit far off. Let me check that one more time. 2 pi minus 0.47. 5.81 rounded. I can't argue with that. And it was close. So those are verified. And that's going to do it for this half of the practice test 2 review for exam 2 for our trig class. So if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.